as a reminder, a complex number consists of a number in the form a plus bi, where a plus a and b are real numbers, and I squared equals -1. Right. Complex numbers form a plus 0i are called. Oh, yeah. And then 0 plus bi are called. Yeah. Thanks. In general, the complex a plus bi, and a is the real part, and is the imaginary part. Should makes it really easy to solve for the real and the imaginary part because you set up the okay. This is written in such a way, so this might be new notation for you. C for RE, right? A plus bi, the real part is the A, and then they use IM for imaginary. That's the B. Okay, and complex numbers denoted by capital C for the number sets. So when you get into that math class that has to do with different sets of numbers, they denote it by different letters. C is like capital C is integers. All right. A squared plus b squared. Oh, let me go back. Did I miss it? Here we go. Yeah, did I miss it? Nope, I did not miss it. Just want to pass this off. Here we go. Alright, so when adding and subtracting complex numbers, we know that we just add the components to each thing, so real to real, and then imaginary. So if R is that, S is that, R plus S is going to be nice, and R minus S is. Okay, just add and subtract the components, just the individual components, the real and the imaginary. Easy day. This is a good idea one. Right? Find two real numbers, A and Q, such that block is block. Right? What do you think? Plug in calculator. Yes. Let's do some math. So, D word? Distribute, yeah. Right? Just distribute. So that'd be 2p plus 3ip plus q plus 2iq is equal to 1. Right? And if you could just imagine, this is 1 plus 0i. So you take the real components, the 2p, and the q, and that should be 1. So 2p plus q is equal to 1. That's the real component. Yeah? Which means q is equal to 1 minus 2p. Okay? Think vectors. Gotta figure out how to fix vectors. Basically, you got a system. Right? The imaginary part is 3p plus 2qi is equal to 0, right? So 0i. So that means 3p plus 2q is equal to 0. Now put ourselves this one. Substitute! Yeah! Let's put that in on here. So 3p plus 2 times 1 minus 2p. 0. 3p plus 2 minus 4p. Negative 1p is equal to negative 2. So p plus b. 2. Put it on the other It's not negative 2. Is it negative 3? It is. Wait. He is what? He is 2. Boogers. Alright. Here we go. That is absolutely fine. Here we go. It is negative 3. Too much. Good stuff. Good stuff. Yeah, man. Alright. Here we go. How do you factor a sum of squares? But sum, right, requires imaginary numbers. So a plus b. Really? And a. It's always 1 plus and 1 minus. So when it was a difference of squares, there's no imaginary number. Right. But if it's a sum of squares, you've got an imaginary number. These two things are called nailed it. Conjugates. Yeah. And the beautiful thing about conjugates is, like for example, if you're trying to find a factor, usually with the imaginary number, if you found one of those things as the factor, then the conjugate is another factor. So, okay, it's coming. It's coming. All right, so here we go. There's R and S again. R times S and R divided by S in the form of A plus BI. So here we go. R times S is equal to 1 plus 2I times, oh, that's supposed to be I, sorry. For that S, is E plus I. Okay? When you FOIL it out, you got 2 plus 5I plus 2I squared. And I squared is -1, so that's not a plus 2, that's -2. So the answer is yeah. Just in time. Yep. We're on example 3 and we'll catch up. Alright? Yay. Alright. Division. Since I is a radical, you must fractionalize the denominator. Alright. So here we go. R divided by S, woo, is going to be 1 plus 2I over 2 plus I. The 2 plus I can't be because I is the square root, so multiply it by 2 plus that 2 minus I, the conjugate. Right? 2 minus I to the top and bottom, because what happens is that bottom just becomes 2 squared plus I squared, right? A plus BI, A minus BI is equal to A squared plus B squared. Woo! Yeah. Yeah. Okay. So this at the top, go ahead and just boil that puppy out. Oh, whatever. Thank you. We got 2 plus 3I minus 2I squared, which is going to be 4 plus 3I divided by. That's fine. Where's the minus I squared? My second set is at minus 2I squared. When you multiply? Oh no! Go back. Go back. So A plus 3I, A minus 3I is A squared plus B squared. Yes, you know why? We squared the I. This is A squared minus 3I. Sorry, A squared minus B squared, right? Square the I, it changes to 1/2. Yeah. Dose! Dose, yeah, but this isn't the difference this time. The sum is just 4. The bottom 3. 4 plus 1. I'm sorry. No, what was the, let me think. Wait, what's the B? Oh, the B is 1. Sorry. It should be a 1, not an I. Yeah. 4 plus 1, whatever the B is, that's why it's 5. You're right, the way I wrote it. Yay? Alright. X is equal to opposite B plus or minus the square. Oh. Quadratic formula? You ready? Here we go. To do the quadratic formula, ready? X is equal to opposite B plus or minus the square. B squared minus 4AC all over 2A. It's good stuff. It's good stuff. So in this case, your A is going to be 1. B is 4, and C is 13, right? It's your coefficient. No big deal. So instead of X, we're solving for Z, no problem. Go IB. Make it interesting. Let's go. So Z is equal to negative 4. 4 plus or minus the square root of 4 squared minus 4, 113, which is 52, that's right, all over 2, 1. Alright, here we go. Oh, goodness, here we go. Negative 4 plus or minus the root of 16 minus 52, negative 36, all divided by, right? Which becomes negative 4 plus or minus 6i all over 2. Clean it up, clean it up. There you go. Right? It's quadratic. Oh, I forgot the minus. Sorry about that. Plus or minus, you have 2 roots. Good times. Alright, so that whole part was reviewed. Ready for some IB now. That's that. That's that. Okay. Here we go. Alright. In the complex numbers, if you have a complex number such as d is equal to x plus yi, then the conjugate would be written as z star. Repeat after me, z star. Woo! Right. And z star would equal, yes, because they're conjugates. Yay. What happens if you add z plus z star? You get 2x. Yeah. Yeah. Z plus z star is going to be 2x. And what if you multiply them? Good on you, mate. Yeah, it's equal to x squared plus y squared, because that brings us back to the sum of squares again. Right? So when you multiply, that's why we have to multiply by the conjugate, because it transforms an imaginary number to a real number. Right? Right? And there's difference. If you subtract z minus z star, what would you get? 2yi is an, yeah. Okay. And if a quadratic with real coefficients has 2 complex roots, these roots are conjugates. So basically, conjugates for the conjugates are the 2 roots of the quadratic. Right? Properties. Property. Go. If you take 2 two imaginary numbers, sorry, two complex numbers and add them together. Then you want to find the conjugate of that sum. Basically, it's the conjugate of the first plus the conjugate of the second. Okay. And for subtraction, same thing. Conjugate of the first minus the conjugate of the second. I do? I feel like I have the same amount of enthusiasm in all my classes. Oh, because, it's Alejandro. What do you want? Here we go. I've already seen it today. Here we go. Same thing for the conjugate of a product. Just find the conjugate of both. Same thing for the quotient of two conjugates. Oh, sorry. Blah, 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 blah. S star divided by T star. Yay? Yay. Okay. More properties. The conjugate of a power. Okay? So, if you have a complex number, take it to a power, then you take the conjugate. It's the same thing as if you took the conjugate of that number and then raised it to that power. Woo! Okay? If you had some type of scalar to it, like an A, just pull the A out. Okay? And then you could also just take the conjugate of the number and then take it to that power as well. All of this, of course, leads up to the conjugate. Okay? Yeah. Okay. And then if you have, you're taking the function to a conjugate, then you could just take the function, so P of Z, and then take that to its conjugate as well. So handy dandy little stuff that you can do with conjugates to rearrange a problem so it's solved. Okay. If P of X is polynomial root coefficients and S is a non-real root for that equation, then S star is also a root. That is that S and S star are conjugate pairs. Okay? Oh my. Oh my. Oh. What? The chem test? Oh, yeah. Okay. Okay. Okay, we're not talking about math, right? It's something else. What is it, chem? I don't know.
You said S star.
S star? Oh no. S dots. Oh goodness. Well, remember, ladies, that chem is tried. Alright, here we go. Chem is tried. Alright. Really quick. So, on your notes, you gotta give yourself a little bit of room. Yeah, good times. Alright, number 6 and number 7, you only need half of the paper to do it. So the rest of it goes to number 5. Yay! Yeah, the other ones are easy. 5 is the long one. Yay? So just kind of, yeah. Okay. Ready? Here we go. Wrapping it up, wrapping it up. Woo! Find all the roots. Find all the roots of 1 plus I to the 4th is equal to 4. So, well, show that. So, in other words, find that Z to the 4th plus 4 is equal to 0. Because remember that Z just means the imaginary or a complex number. So, pretend Z is 1 plus I. Yay? Sure. Okay. Imagine this, right? We gotta break it down. So we're taking it to the 4th power. So obviously we can like divide that, get a square out of it somehow, right? So if you go 1 plus I squared, just seeing what that would equal. That would be 1 plus 2I plus 2I squared. Oh, I'm sorry, not 2I squared. That's just a, sorry, that's a 1I squared. My bad, my bad, my bad. Right? This would be a 1, and that's a negative 1, so that would just be 2I. Okay? Therefore, you ready? 1 plus I to the 4th would just be 2I squared. Yeah, yeah. Okay. And that would be 4I squared. So negative 4. Right? Therefore, because it equals negative 4, right? Because remember, we're pretending this is z. And if you square it and you get negative 4, that means 1 plus I is a root of z to the 4th plus 4 equals 0. So this is 1. How many roots are we supposed to have? 4! We gotta find 3 more! Yay! Alright, the second one is easy. If 1 plus I is a root, then 1 minus I is a root. Right? Here we go. 1 minus I is a root 2. Right? If 1 plus I is a root, then the other one is a root also. Okay. So here's what happens. Alright, I'm going to write on this side just to give myself some more room. So, alright. So, yeah. Z minus 1 minus I and Z minus the quotient 1 minus I, which is equal to Z minus 1 plus I, are both factors of Z to the 4th plus 4. Right? Those two are both factors of Z to the 4th plus 4. So what you do is you FOIL them out. Okay? Because that is going to be a quadratic, so that's 2 of the roots. To find the other 2, we need to find another quadratic. Alright, so you go Z minus 1 minus I and times Z minus 1 plus I. Yeah, so since these 2 are roots, hang on, these 2 are root, you want to find, go ahead and FOIL them out and make them the quadratic, and then we're going to find the other part of the quadratic to find the other 2 roots. Alright, here we go. Right? This is equal to, do you agree that if you look at this as A right here minus BI and plus BI, so this would be the same thing as, wait for it, Z minus 1 squared plus, minus I squared, which becomes the plus 1. Yay? And if you were to FOIL this out, it would simplify to Z squared plus 2Z plus 2, right? This is 1 plus 1. Where is it? No, he's right. It is minus 2Z. Genius. Genius. Delete, delete, delete. Okay. So Z squared minus 2Z plus 2. True? Okay. So imagine this. This means, therefore, right, using these 2 things, that Z to the 4th plus I, is that what we're doing? No, plus 4, is equal to that quadratic times another quadratic. Well, not necessarily. Not necessarily. I'll show you. So that's equal to Z squared minus 2Z plus 2 times some other random, that should be a Z, sorry about that, plus B, C plus C times another quadratic. Okay, so watch this. Here we go. If you were to FOIL all of this stuff out, you would get a z to the fourth plus b minus 2a z cubed plus c minus 2b plus 2a z squared plus negative 2c plus 2b z plus 2c. That's just if you FOIL everything out and just combine all the c to the fourth, c to the third, c squared, and so on. We're at b minus 2a. That is correct. Well, like I said, if you were to FOIL everything out and just group all the cubes, the fourths, the squares, and everything, that's what would happen. So trying to say it's based on your paper, I kind of did a bunch of work for you. Yellow. Because Monday is the best day. Alright. Here we go. Now. Here we go. Now, if this is true and these two things are equal, that means a z to the fourth has to be z to the fourth. Right? So z to the fourth has to equal a z to the fourth, which means that a has to be n. Okay, that's a good thing to know. Yeah? Notice that. Yes! Right? Okay. Notice that there's no z cubed. Exactly. So that means this part right here has to equal 0. So b minus 2a has to be 0. Since we know a is 1, then b has to be a. Or b. Sorry. Here we go. Well, we now know a. We now know b. Let's find c. Here we go. Isn't this the easiest one to find? Right? What is it? The 2c at the end? You're a flippin' genius. Yeah, you're right. Since the end is the 2c, then 4 equals 2c. That means c has to be 4. Right? So, the second, quadratic factor is 1, so z squared plus 2z plus 4. Yeah? So to split that up into smaller factors, quadratic formula. There we go. 2. Why did I say 4? I'm so silly. Ugh. Yeah, alright, I'm going to do that again. Hang on. So 4 is equal to 2c, therefore c equals 2. There's that. So this thing, I forgot what Maria. Here we go. C squared plus 2z plus 2. Okay? Which one? The 2z, the b is 2. So it's literally 1, 2, 2. 1, 2, 2. Yay. Alright. So to find the last two factors, all of that, just to find 2 more factors. Good times. C is equal to opposite. Plus or minus the square root of 2 squared minus 4 plus 2. plus or minus something over 2, 4 minus 8. So 2 plus or minus 2i over 2. So 1 plus or minus negative 1 plus or minus I are the next two roots. So let's clean it up. The roots of e to the 4th plus 4 equals 0 are 1 plus or minus I and negative 1 plus or minus I. Ta-da! No one appreciates this. Oh well. Do you want to see a picture of this? The picture of the roof. Yeah! I show you picture. I show you picture, yes? Yeah! Here we go. Here's a picture of all the roots, right? There's 4 of them. There's one at 1 and I, so there's right here. There's that 1 and minus I, so that's here. Negative 1 and negative I and negative 1 and positive I. Right? That's called an Argand diagram of all the roots. Usually it's a circle. Oh, whatever. Here we go. That's good. That's good. Okay, remember, all of this is before DeMoss. So DeMoss will make our life easier later. All right, but this is how you do it by hand without DeMoss. Last two? Last two. Here we go. Find the square roots of it, I. So how many solutions? 2. Thank you. All right. So. Right? If change that into, like for example, you set it up as a square and you do a plus ai, you have to remember the following, right? A plus bi, once you square that, is going to be a squared minus b squared plus 2abi, which all it did was move the b squared to the other side, so that a squared minus b squared is your real term now. So this part is your real, and then this part is your imaginary. Right? So I'll switch it up. So therefore, go ahead. Yeah. Yeah. The real term of this thing is 0, right? And 2ab is equal to 8. Okay? So b is equal to 4 over a. And a squared minus 4 over a squared is equal to 0, which means a squared is 16, which means a is plus or minus 4. Yeah. Therefore, b would have to be plus or minus. You plug in b right here for a right there. 4 divided by, sorry. Yeah, 4. A squared is 16. Did I mess it up? Probably. No, it's, yeah, you're right. It's 2, right? So a squared is not 16. It's 4, right? Sorry about that. Let me fix this up. Let me fix it up. Sorry about that. Here we go. delete. So if you add it to the other side, you'd have a squared. Yeah. You'd have a squared is equal to 18 or 16 over a squared. Yeah. Here we go. So you would have a squared is equal to 16 over a squared. So a to the fourth is equal to 16. So that means a has to be plus or minus 2. My bad. Because the fourth root of 16 is 2. Right? Okay? If you divide 4 by positive 2, then you get b is positive 2. And then if you divide by negative 2, then b is negative 2. Right? So the square roots are, sorry, 2 plus, or, sorry, plus 2i, and negative 2 minus 2i. Yeah. You're going to need 2 roots, right? Yeah, it is. It is. Joy? Not Joy? Aww. Aww. Alright, last one. We are going to eat that cinnamon in less than 2 minutes. Oh, here we go. Here we go. Oh my gosh. Alright. Last one. This one has actually a real component to it. Yay. Alright. So, if a plus b I squared is equal to 3 minus 4i, then a squared minus b squared would be 3. Remember, that's the real term. And then the 2ab would be negative 4. Okay? So b would be negative 2 over a. Plug it this way. So a squared minus negative 2 over a squared is equal to 3. Hey. A squared minus 4 over a squared equals 3. Multiply everything by a squared, so a to the fourth minus 4 equals 3a squared. Set it equal to 0, so a to the fourth minus 3b squared minus 4 equals 0. Factor. Squared minus 4b squared plus 1. Right? Over here, this one could be a root, but you would end up with a squared equals negative 1. It can't be because we're looking for the a term, which has to be real. So the other one is the only one we use. So a squared minus 4 is 0. So a is equal to plus or minus 2. Sure. Okay. When a is equal to positive 2, b is equal to 1. When a is equal to negative 2, b is equal to positive 1. So the two roots are 2 minus I and 2 plus I. And they all live Cinnabonly ever after. Okay, grab your Cinnabon, grab your take-home quiz. If you get done today, you can turn it in your iPhone. God bless us, everyone. Let me grab some napkin.